Hello and welcome to section 2.1, which is on patterns and inductive reasoning. Inductive reasoning is reasoning based on observed patterns. Basically the answer that you get to your inductive reasoning is going to be called a conjecture. Okay, whatever conclusion you come to after using inductive reasoning by looking at the patterns of what's happening, the answer is called a conjecture. For example, what conjecture can you make about the 25th term in the sequence RWB, RWB, and so on? If you keep going there and actually write it out, which you can do, you'll end up with a B at the 21st term. Why is that? If you look at the pattern, every third letter is a B, and 3 is a multiple of 21, so you know that the third one, if you keep going, every third one is going to be a B, which makes it the 21st term is a B. So to make a conjecture, depending on the type of problem that it is, you might need to collect more information or use data to make a prediction about it. And we'll do some of those in class. A counterexample is an example that shows that a conjecture is incorrect. So if I make a conjecture, I make my prediction, and then I go test it, or somebody else tests it, and finds that it's not right, okay, in any circumstance, they find one example of when it's not right. That's called a counterexample. For example, I have when you multiply a number by 3, the product is divisible by 6. So if that's what I think, that's my conjecture. You're going to test it, and if you find one example that is incorrect, then I'm wrong. You have found a counterexample. And I did find a counterexample to this one. 3 times 9. That's a multiple. If you multiply a number by 3, so 3 times 9 is 27. You take 27, you try to divide it by 6, it does not come out evenly. Okay, so that right there would be a counter example. Bring this information with you, and we will talk about it next time I see you. Have a good night.